Okay, so in the first question, we've got solve the equation 4x minus 5 in modulus sine equals 3. So first of all, we just think about the sketch of this, and I just end up going for drawing it rather than, or sort of using the computer program to draw the graph. So we'd have 4x minus 3 as sort of shown here, going past minus 5. And what the modulus basically does is it puts that back up so we don't end up with negative answers. So if I reflect that back up and then we're putting in equals 3, and that's kind of what our sketch looks like. And it's always useful to sketch just so that you understand what we're kind of ending up doing. So we've got 4x minus 5, that's this line here, and that equals 3. Well, we could just solve that normally. So if I just change to the ink, we can then say, well, we've got 4x minus 5 equals 3, add 5 to both sides. So we end up with 4x equal to 8, which gives us x is equal to 8 over 4, which is 2. And that seems to match up to our drawing there. Now for the second one, we've got this line here. Now this line is actually just, it's got the negative gradient of there. And you can see that if you put a negative in there, it would also cross at plus 5. So we actually get negative 4x plus 5 equals 3. And again, some people just put the negative onto the negative 3 and do it that way. So we end up with negative 4x is equal to minus 2. So x is equal to minus 2 over 4. So a half. And again, if we look at our points there, I think that's 1, there's a half. So it seems to match up to x equals a half. Second one, prove that cosec theta minus cot theta all squared. So first thing I'm going to do is I'm going to look at replacing that. So that's 1 over sine. Remember the third letter tells you what it is. Minus 1 over tan theta, and this is all squared. Tan is sine over cos, which means that I'm going to get 1 over sine theta minus sine over cos, so it becomes cos over sine. Oops, sine theta. We've now got a fraction, so we can combine the top, so we end up with 1 minus, oh, sorry, this is all squared. So 1 minus cos theta all over sine theta. Now at this point, we now probably have to put in the squaring first of all. So we end up with 1 minus cos theta, and that's going to be squared. Now just remember that that means 1 minus cos, 1 minus cos, and the bottom becomes sine squared theta. At this point, you might sort of be looking at multiplying these out and looking there, but now I'm going to look at the answer. 1 minus cos, so I seem to have 1 minus cos here, so I need to get rid of one of the 1 minus cos, which means my sine squared has to disappear. Now remember that sine squared plus cos squared equals 1, which means that sine squared is going to be, so let me just write the top one, because I know that one of these are going to have to disappear. 1 minus cos theta. And I know in my final answer that one of these has to go. Now sine squared is 1 minus cos squared theta. So now I've got to kind of think this bottom line, how can I get it to be 1 minus cos? Well, this is actually a difference of two squares. So again, if I write, it's going to look a bit bad. So 1 minus cos theta in one bracket, 1 minus cos theta in the second bracket. And on the bottom, because of the difference of two squares, 1 minus cos theta and 1 plus cos theta. Again, you can check by multiplying out, but they do cancel, which means that and that cancels, leaving the right-hand side, which would be, and then I've just eaten that, but I've just kind of run out of room, so I'm not going to put that down. Hence solve the equation. Now, when it's saying hence solve, if you didn't get the answer, you would be looking at writing your answer like this, because this bit looks a bit messy. We're going to write it like this. So it equals 1/3. So we're looking at 1 minus cos theta, and I am going to bring my 3 up there, and the other line I'm going to multiply up by the 1 plus cos theta. Okay, so all I've done there is my third was on the right hand side. This bit here was actually just that, so I've multiplied by 3 for the 1 minus cos theta, and I brought this up so to match with this 1. And obviously the 1 just is staying the same, so I can multiply this bracket out. So 3 minus 3 cos theta equals 1 plus cos theta. Get things to the same side, so I'm going to add my 3 cos theta. So we end up with 3 equals 1 plus 4 cos theta, and take away 1, so we get 2 equals 4 cos theta, which gets you a half is equal to cos theta. And we can now solve this using our calculator, which I just realized I don't have right now. So I'm probably going to stop it there, but you should then be able to get your answers for their cos of a half. I should know that because it's an exact value, but right now on a Saturday night I can't remember. So once we get that, all schools teach children, once you get your principal values, because it's a positive, A, C, so it's going to be 360 minus that, and you'll get your other answers.